So as always, we start with creating a project, and we use the templates in Maven to do that. We have a handy Hello World template, which allows us to start easy. I'm going to call our project Ruby on Rails. What this does is a set of generating a set of files. It basically creates a project structure, and it gives us also a deps.eden with the dependencies for running an environment, the REPL environment. Deps.eden, maven.eden, and then one file core.clj, which has nothing in it. But the deps.eden is handy with these dependencies. But as you see, the main map in deps is empty. So now we can start the REPL. Maven-a and REPL. -a means alias, and REPL is an alias command. So I connect to the REPL, Maven connect, and then I don't need this. So I'm starting fresh with a new namespace. Now David starts by creating a database. No, David starts by generating code, which we don't do. This is the whole point. We're not doing any kind of magic. We're going to write everything from scratch. So I'm going to create a database now. Create the database block development. Then I want to use it, switch to it. So I'm going to create the first table. David creates the post table, and we're going to do this here. It has 3 columns. Actually, we're going to start with 1 column or 2 columns, ID and title. Yeah, so varchar 255, that means a string of 255 characters maximum. And the ID will be auto-increment, and it will be the primary key. So the way we're going to structure our application is by focusing on each of the layers separately. And we have 3 layers. We have SQL layer, we have the web server layer, and the web server logic, if you will, and then we have the presentation layer, the HTML. With the Ruby on Rails demo, they are separated in terms of controllers and model and stuff like that. There's no abstractions like this in our case, because that's the whole point of the exercise. No abstractions on top of the existing technologies, SQL, handlers, and HTML presentation. So the first part is going to be about the SQL. I'm going to create a database, create a table that we need, the first table that we need, and then be able to talk to the database from our Clojure program. And how are we going to achieve this? We're going to use the Java built-in classes to talk SQL. So our first dependency will be the MariaDB connector. So I'm going to create an SQL file, and I'm going to import SQL driver manager, and the driver manager will use a a URL, and with this protocol and scheme, it knows to look for the connector in the class path. Okay, so this is my URL that I can use to make a connection to the server. How do I do that? Let's try it out. Driver manager get connection, a static method, and then GDBC. Okay. So once you have a connection, create a statement. That's how it works. That's how the Java interrupts works. So this is a statement. And with the statement, you can call execute query. So executing a query returns a result set, select result set. As you can see from the object returned. Here I'm inspecting it. Okay, so these are my results. So Clojure provides a handy function in the built-in library called result set sec, which will transform the rows that you get back from the database into lazy sequences. And here is my results. So if I want to see the columns for the table, I can execute a query show columns, and then the results are the two fields that we have in this table, ID and title. And if I run again result set sec on the results, it gives me nil. So this is stateful. Summing up the REPL exercise we just did, we can write our first lower level function to execute queries, and that will be a function that takes a URL. Let me call this URL, and a query. And what we will do is, I will explain what with open does in a minute, but first I want to recreate those objects. And then what we did was feeding statement to execute query. And on this, calling result set. What with open is a macro, a typical list macro, which takes the bindings, connection and statement, and calls a close for you automatically when it exits. So here I'm expanding the macro. You can see there is a finally close here, and it calls close on the statement and close on the connection. First on the statement, then the connection. So it takes these bindings and it will call close in the reverse order of how the bindings appear in this block. So you don't have to do it. That is a typical list macro. It's available for doing I/O or all kinds of stuff. And now we can call execute query, and I will give it JDBC URL, and I will say show tables or show columns. Okay, now the other function I will need, the lower level function at this level, is execute update, which will be very similar to execute query, a little bit simpler, because when you do an update, you don't need to receive results. You just need to receive a result code, whether the operation succeeded or not. So this execute query, I can copy and paste, change here the name to execute update, and here I want a command. I open a connection, and then I create a statement, and then on the statement I do execute update, and then the command, and then I don't need this. Okay, so that's execute update. I can, for example, create my first title, my first post. So this is our first in creation, post creation, and this is how you use execute update. Now I can query select everything from post. So if I select, if I type here hello indeed, so now I have a mechanism to executing the updates and the queries, and that's all I need. There's nothing else. Okay, we're going to create a new namespace called posts. So here we're going to refer to what we did just now: execute query, execute URL, and the JDBC URL. So the purpose of this namespace is to create the CRUD operations: create, read, update, and delete. And that's it. We already did a create. Created text title, and then actually I can copy this from here. So I need to concatenate this. Okay. I'm going to switch to this namespace and try it out. Hello indeed. So I want to save this as well. Call it list. Make it a function. So if I do list now, that's what I need to do. And if you notice this warning, list already refers to Clojure core.list. So this is a warning that I can get rid of because I'm not going to use the built-in list. I want to use my list. So I'm going to right here in the namespace declaration, refer Clojure, exclude, and list. Okay. So I have a create. Now I want a update. I want to change my title. So I'm going to the update. I'm going to pass in title, and it will be very similar, except that instead of doing an insert, I call update. Let's try it out. I want the last one, 4 here. I want to change it to so I don't need this. Yeah, there was this extraneous parent. So now I can do list, and as you see, the last one was changed. Let's change also the second one because it's duplicate. So I'm going to change here. Hello Denmark. Okay. So we have the create, the update. So read, same thing. It exists in the Clojure built-in library. I'm going to exclude it as well. And then I can say read 1, read 2, etc. And now I only need the delete to be very similar to the read. So I can copy it and I do here delete. So let me try it out. Delete 4. Yes, that's good. Okay, we have our CRUD operations ready, and that's all we need to on that for the SQL layer. We can move on to the web server layer now.